Okay. I posted what a practice AP exam. Now, just to be clear, it's really easy, but I thought rather than try to come up with a really complicated question, I thought I would stick with the ideas that I think are important here. Um, so the first thing is I think, and I could be, again, I could be full of crap here, so I don't know, right? I think that they're going to give you a graph, and then and they're going to say that graph is the g is the integral of that graph. So you want to realize that that graph is really the derivative of g, and then if you take the derivative again, the second derivative of g would be the derivative of f. Okay, I think that's how they're going to address it. Now, just because it's a way to draw these things without having to be able to put into Wolfram Alpha or Google or anything like that and get the right answer. So, I mean, I just think that's why they're going to do it. Also, you can test the 7 big ideas. Remember the 7 big ideas from the first semester: increasing, decreasing, concave up, concave down, inflection points, maxes and mins. Okay. Now, the only part of this one that's going to be a little tricky, and not now, but later, is this cosine wave here. The rest are straight lines or a half a circle, which we can figure out the areas later. So just to be clear, I do think that they're going to make one part of the curve not a geometric shape of some sort, like not a half a circle or a trapezoid or a triangle, right? So I think they're going to make one part where you're going to have to do a little bit of antiderivative. Kind of something that Katie asked about at our last meeting is that, and it'll be pretty simple. It'll be a little piece where you have to do an antiderivative by hand, okay? But in conjunction with a question where you can't, so your final answer won't actually be accessible just by Wolfram Alphaing that one part. And it'll be easy enough that you're not going to want to try to Google it or come up with the answer. You're going to just want to work it out because it's going to be faster to work it out by hand. Okay, just a reminder of how to do these 7 questions. When is g increasing? When the derivative is positive. When f is positive, so here to here. So from -2 to 1. When would g be decreasing? Well, when the graph is negative. So it's negative here and negative here for the half circle. So negative from -5 to -2. And also from 1 to 5. Now, when is a function concave up? Now remember, do the logic on this. A function's concave up when the second derivative is positive, or f's derivative is positive. Well, when was derivative positive? When it's increasing. So what you want to think to yourself here is this is concave up. G is concave up when f is increasing. Because when f is increasing, then f's derivatives are positive. So it's increasing here from -4 to 0. And right, it's because it's a half circle, we know that that's going to be right the halfway point between 1 and 5, which is 3. Sorry, 3 to 5. And then when is it concave down? Okay, when would g be concave down? G is concave down technically when its second derivative is negative, which means when the derivative of f is negative. Well, when is a derivative negative? A derivative is negative when the function is decreasing. So down, oh wow, it keeps going here. So I was going to stop here, but don't. It keeps going all the way here. So from 0 to 3. And things that are probably pretty obvious, you can double check. -4 to 0, and then 0 to 3, and then 3 to 5. You might go, what happened to, it's second derivative is 0 there, isn't it? Right? The slope's 0, so that means the g's second derivative is 0, so it's not up or down. So notice that straight line is not there. Okay, relative max. Relative max is when the derivative changes sorry, when the derivative changes, when g's derivative changes from positive to negative, or when f changes from positive to negative, right here. Goes from positive to negative right there. Basically looking for the derivative of 0, right? So right there, 1. Now that's not the actual y value, but I want, the question I asked you is where will that happen at? What is the relative min right there? Because the derivative is 0. Because remember, the derivative is f. F is a value of 0 there, and it changes from being negative to positive at -2. Now, where would the inflection points be? The inflection points are going to be when the second derivative changes signs, or when that would mean when f prime changes signs, or when f's derivative changes signs, and that would be when f changes from increasing to decreasing. So increasing to decreasing, so right there at 0, and then here is decreasing and then increasing, so right there at 3. And of course, you can kind of do these, you'll see the 1 is going to appear here when you look at increasing to decreasing, and the 2, -2. Not 2. -2. And then the inflection points will show up with the concavity, right? The 0 and the 3 will show up here. Obviously, you got the 5. Now, the reason that's not -5 is because of the straight line there. Anyways, I know, that you might think, boy, you're making this seem like it's really easy. Yeah, I don't know what they're going to ask, but I just wanted to kind of go over the main 7 ideas that we learned, and they're going to probably ask them in a little more challenging way than this, but I thought this was a good starter question for just so you don't panic on the test and go, well, wait, there's 7 big ideas, right? Increasing, decreasing, concave up, concave down, max, min, and inflection points. And they're going to ask you some questions about those. Okay, so there's the answer to the first question.